My dear grade 8 student, so this is the first lesson in the second term. What is that lesson? Symmetry, right? So we can learn by studying this lesson. You will able to learn, definitely you will able to learn how to identify the rotational symmetry of a plane figure, then how to find the order of the rotational symmetry, right? Rotational symmetry and what is the order of rotational symmetry, those things, right? You can cover it by using this lesson. Don't worry. So we can learn up to A to Z, right? Now I'm quickly moving to recap what are the theory lessons you just covered in grade not 8, grade 7. In grade 7, have you remember that one? Grade 7 first lesson, no? Yes, grade 7 first lesson, what is that one? Symmetry. Bilateral symmetric plane figure, have you remember that one? Right? We just identify what are the plane figures, right? Then when you fold into two lines, it will coincide with the other side. Then you can get two equal parts like heart shape, right? So you can get two equal parts. That is the meaning of bilateral symmetry. You learned in grade 7, if it possible to fold a plane figure, right? If it's possible to fold a plane figure through the line, through the line on it, right? Then you can get two equal parts which coincide with each other. Which coincide means which coincide means you can get two equal parts, right? You can get two equal parts. Now look at this one. So I have a semicircle shape. I have a semicircle shape. I'm just going to fold this plane figure through this axis. I'm just going to fold this plane figure through this axis. Then using that one, you can get the bilateral symmetric plane figure, right? Then I can show you some examples, right? Look at this one. Then I have a square, right? Look at this one. I have a square, right? Okay. Then I'm just going to fold into two equal parts, right? Then you can see that one. Then I'm just going to fold into two equal parts. So I can get the bilateral symmetric plane figure. So this is the bilateral symmetric plane figure. That means bilaterally symmetric plane figure, right? Symmetry of the plane figure, right? So I'm just going to recap that memory, right? Look at this one. Look at the semicircle. I'm just going to fold that one through this axis, fold this one through this axis. Right, okay. Then you can get two equal parts, right? Look at the heart shape. If I'm going to fold in through this line, then I can get two equal parts. Look at the square. Square, many axes of symmetry. Then you can fold into this axis, then you can get two equal parts. I can fold through this axis, then you can get two equal parts. I can fold through this axis, then you can get two equal parts. Again through this axis, then you can get two equal parts. Fold means one now. So if you are going to fold through this axis, so you can get two equal parts. So that means bilateral symmetric plane figure. That axis, have you remember that one? That axis is known as axis of symmetry. Axis of symmetry. Those are the things you just learned in grade 7, right? In grade 7, right? Okay, the two parts on either side of an axis of symmetry of a bilateral symmetric plane figure are equal in shape. Look at this one. This shape 100% equals to other side of the heart shape. This shape 100% equals to other side of that semicircle. Those two parts are equal. Those two parts are equal in shape and also the area. And area is also equal, right? So I think this is the summary you just learned in grade 7. What is that one? Axis of symmetry, bilateral symmetric plane figure. But in grade 8, that one is so interesting. We are not going to fold in grade 8. So we are going to rotate on right me. So we are going to rotate. අපිට grade 7 වලදී fold කරානේ. හැබැයි grade 8 වලදී fold කරන්නේ නැහැ. Grade 8, so we are going to rotate. අපි කරකවනවා මේක මෙන්න. So we are going to rotate that one. Right? So we are going to rotate. Then we need to find down what is the order of rotational symmetry. Right? I'm just going to take that one from the first figure. Right? Let's start from square. Let's find out what is the order of symmetry, what is the meaning of order of symmetry, what is the axis of symmetry, what is the meaning of bilateral symmetric plane figure. Let's identify all the concept here. Right? Just quickly draw this one. Symmetry, then you can draw these shapes. Right, okay. Then these axes are called as axis of symmetry. Just quickly draw this one. Just quickly draw these plane figures. Right, okay. Axis of symmetry. Axis of symmetry. Just quickly note it down. First topic, what is rotational symmetry? My dear student, look at this one. A shape has rotational symmetry when it looks like the same after some rotation. That means, right, don't worry, I will explain you by taking an example. Right, look at this one. Then I have the rectangle. So you can see the green color rectangle here. Right, okay. I'm just going to place that on the whiteboard. Right, okay. Now look at this one. Then you can place that one on the whiteboard. Close look at this one. Just try to understand the concept here. Right. Then I'm just going to explain what is the meaning of rotational symmetry. Easy, very easy. Have you remember the grade 7? Axis of symmetry. Axis of symmetry. Axis of symmetry means you can fold this one into two. You can fold this one into two. So you can fold this one into two. By taking this axis, you can fold this one into two equal parts. So that axis is known as axis of symmetry. But here, grade 8, so we are going to consider the order of rotational symmetry. Now look at this one. Then I'm taking that figure, right, okay. Then I'm just going to mark the boundary lines. Right, 1 and 2, right, then 3 and also 4. You can see this one. I'm just going to mark the starting point, and this is the starting point. You can see that one clearly, right? I'm just going to rotate through the center point. I'm just going to touch in the center point, and I'm going to rotate that figure. Look at this one, Lamai. Then I can rotate that color. Then you can rotate. After this example, you can practice this one. Then you can observe. You can observe this one by yourself. That is the way of learning, right? Look at this one. I'm taken into the original place. Right. Look at this one video. Now I'm going to rotate this one. Right. No. Then right. Then I'm rotating. Still rotating. Still rotating. Now 90 degrees completed. But it not looks like the original shape. Original shape means original shape. You just remember that one in the landscape format. So this is on the portrait format. This is not the original shape. Now I'm just going to rotate, continuously rotating by itself, right? Rotating, no, rotating, no. Now you can see, then this one is equal to the original one. Then how many times, right, after symmetry, How many times look like the shape? One time. Now look at this one. That mark is there. For a one rotation, this mark should be coincide with this one, right? Then I can rotate more, right? Okay, I'm just going to rotate this one again, right? Again, 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 again. Yes. Then how many times? Two times. Then how many times a shape has rotational symmetry means how many times it looks like the original one. That means two times. How many times? Two times. Now I'm just going to fast forward that one. Video, right? No, no, no. Right. First one, first one, first one, first one. Then first time is done. Then creating this one, right? Okay, okay, okay. Look at the second time. Look at the second time. So that means how many times it will coincide with the original one? Two times. Two times. That means order of the rotational symmetry equals to 2. Now look at this one. Now look at this one. Then what is the meaning of order of rotational symmetry? Right? Then how many times it matches as we go once around it called the order. How many times it will look like the original one. That means order of rotational symmetry. How many times it will coincide with the original one? Two times. Then what is the order of rotational symmetry of a rectangle? Two. Right? Then I think that one is very clear. Right? I'm just going to clear this one. Then what is the order of rotational symmetry? Look at this one. What is the order of rotational symmetry? What is the order of rotational symmetry? Right? Symmetry. That means how many times it matches as we go once around it called the order. Now look at this one. Again, I'm taking once more. Right. Look at this one, Pedro. Right. I'm taking a rectangle. Then look at this one. How many times? I'm quickly moving to the borders. I'm just going to mark the borders. 1 and 2, 3 and 4. Look at this one. Right. What is the order of rotational symmetry? Right. Wait. Again, I'm just going to do this one. Right. Just do that one with me. You can do this one with me. Right. I'm just going to rotate this one. No. I'm just going to rotate this one. No. I'm just going to rotate this one. No. Then still I'm rotating that one. Right. Okay. No. 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 Right. That's okay. That means how many times it will coincide with the original one? One time, one time. I'm doing that one again. One, no, no, no. Right, look at this one. Then how many times? Two times. How many times? Two times. Just try to do that one with me. Take a piece of paper and quickly do that one with me. Two times it will coincide with the original one. Right? Okay, then you can observe this one by yourself. Just quickly try to do this one quickly. Then what is the order of rotational symmetry? Order of rotational symmetry means how many times it matches as we go once around is called the order. How many times it matches? How many times? How many times? It will coincide with the original one. How many times it matches, right? How many times it matches as we, right? As we go once around it, right? Around is called the order. Very good, very good, very good. Quickly do this one video. Quickly write down this one. Right. Then we can observe what is the order of the rotational symmetry and the axis of symmetry of the each plane figure. Okay, right. Quickly moving to the first figure. What is that one, my dear student? Rectangle. Number of axes of symmetry. Then I'm just going to complete this part, right? Number of axes of symmetry. Look at this one. Then you can fold through this axis, right? You can fold through this axis. Then you can get two equal sides. Not only that, you can fold through this axis, right? Then how many axes of symmetries are there for the rectangle? That means 2. Number of axes of symmetry, that means 2. Order of rotational symmetry, we just observed that one couple of minutes before. What is the order? How many times it is equals to the original shape? Key parak kaling shape එක වගේ වුණාද? How many times? 2 times. So that means order of the rotational symmetry equals to 2. Order of rotational symmetry equals to 2. Right? Then what is the next shape? I'm quickly moving to the square shape. Then, right, just quickly note it down. This is the first shape. What is that one? Rectangle. Right? What is that one? Rectangle. Then I'm quickly moving to the square shape. Right? I'm quickly moving to the square shape now. Look at the second shape. You know the shape. What is the name of that shape? Square. Yes, very good. So that means square. Square means all 4 sides are equal and all the angles also equal, right? Number of axes of symmetry and what is the order of rotational symmetry? Let's try to do this one. Chuta balamu api. Square. Square means then I have that shape, then I will show that one into you, right? Look at this one, lamai me tiyenne on the right. Square, right? Let's observe how many axes are there for the number of symmetry, right? So that means one axis and 2 axes, right? Look at this one. 1, yes, then you can see that one. So we can fold like through this axis. That means 1. Then we can fold through this axis. Right. Then you can clearly see both sides are equal. Right. Very good. Then Lamai, is that all? No. Look at this one. We can fold through the diagonal. Diagonal means from this line. May on the right. Then same for the other side as well. Right. We can fold through the diagonal. Very good. Then we can fold through this axis as well. Nearby. Then how many axes of symmetries? How many axes are there for the symmetry? 4 axes. Right? Now, grade 8 one, we need to find out how many times it will coincide, it will equal to the original shape when you are rotating one round through the center axis. Right, wait. Now I'm just going to do this one. Right, I'm going to mark the borders. 1. Can you see this one? Huh? Right, wait. I'm just going to mark the borders. 1, 2, 3, and 4. Right, very good. Now look at this one. I'm just going to rotate that figure. Then you can count that one with me. Right, wait. Right, no. 1 time, 2 times, 3 times, complete rotation, 4 times. How many times? How many times it will equals to the first one, right? 4 times. Look at this one. I will do that one again. 1 time, 2 times, 3 times, and 4 times. How many times? 4 times, right? That's all. So that means, what is the order of the rotational symmetry? That means 4. Lamai, look at this one. For the first one, part A, have you remembered the order of rotational symmetry on the rectangle? 2. Order of square, right? Order of square, order of rotational symmetry of the square. That means 4. I'm quickly moving to the third one. What is the third one? Equilateral triangle. Equilateral triangle means triangle which all sides are equal, right? Which all sides are equal. Third shape, I'm quickly moving to the third shape. That means equilateral triangle. Then you can write down next one. 3, right? Equilateral triangle. So you need to write down this one and just try to do this one with me. Then you can take the nice figures, right? Then you can separate the paper, separate equilateral triangle from the paper. Then you can do that practical with me, right? Equilateral triangle. Equilateral triangle. That means triangle with all sides are equal. I'm just going to draw that one, right? I'm just going to draw this one. Equilateral triangle, right? 1. Then you can draw this one. 2 and 3. All sides are equal, right? Equilateral triangle means all sides are equal. Order of rotational symmetry. Order of rotational symmetry. Order of rotational symmetry. Equilateral triangle. Now look at the figure. Then I have the figure. Right. This one. Right. Then you can see this one. So this is the figure. Right. Equilateral triangle. Then you can know, right. Just try to do that one with me. Number of axes of symmetry, very clear. I can fault through this axis. I can fault through this axis, right? Then I can fault through this axis. How many axes are there? 1. Very good. Then I can fault through this axis, right? That means 2, 3. 3 axes are there for the symmetry, right? Very good. Then how many axes of symmetries are there? That means 4. Sorry, 3. 3 axes of symmetry. Now I'm going to rotate this one. Wait. Right, okay. I'm taking this one. This is the starting point. Look at this one. This is the starting point. 1 and 2. And this one equals to 3. Right, very good. 1, 2, 3. Lamai, look at this one video. Just count how many times it will take the original shape within one rotation. Right, look at this one. I'm rotating. No. Yes. How many times? 1 time now. Look at the rotation. I'm just still here. I'm going to rotate, continuously rotate this one. No. Yes. How many times? 2 times. Then I'm just going to rotate that one. No. Then how many times? 3 times. How many times? 3 times. Then just quickly tell me what is the order of rotational symmetry. Then order of rotational symmetry equals to 3. Order of rotational symmetry equals to 3, right? I'm just going to consider another 2 shapes. That means regular pentagon and the circle. Let's try to do that one, right? quickly draw this one and mark how many axes are there, and just try to observe that one, what is the order of rotational symmetry. Right. Quickly note it down, Lamai. Right, my dear student. So this is the next shape. What is that one, video? That is parallelogram. What is that shape? That one is parallelogram, right? Then look at this one. There are no any axes of symmetries on this plane figure. There are no any axes of symmetries on this plane figure. But then I can write down, then you can check this one at your home. There are no any axes of symmetries in this plane figure. So number of axes of symmetry, that part equals to 0. What is the order of rotational symmetry? To observe the order of rotational symmetry, then we need to rotate that one. Right, look at this one. I'm just going to rotate this one. Right, okay. I'm just going to rotate. No, no, no. Right. Look at this one. No, this is not the original shape. This is not the original shape, right? This is not the original shape. The original shape anyway. Then I'm just going to rotate this one more. No, 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 no. Then yes, very good. Now that one is equals to the original shape. This is original shape. Then how many times it will equals to the original shape so far? That means one time. Then I'm going to rotate that one more. Rotate. No, 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 no. Look at this one. Right. Very good. Then how many times? How many times, video? 2 times. How many times? 2 times. 2 times it is equals to the original shape. So that means 2 times is there. Order of rotational symmetry then equals to 2. Then what is the number of axes of symmetry? What is that figure? What is that figure? That is the important part, right? What is that figure? Parallelogram, right? What is that figure? Parallelogram. So parallelogram is the shape. So how many axes of symmetries are there in this figure? Number of axes of symmetries are there in figure? No any axes of symmetries are there, but order of symmetry equals to, order of symmetry equals to, what is that one? Order of symmetry equals to 2. I'm just quickly moving to the shape name. Then you can write down this one. Just quickly note this one, right? Parallelogram. 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 Lamai, there is a shape. It's just like the parallelogram, but small difference is there. What is that one? Rhombus, rhombus. Right. I'm just quickly moving to the next one. So that means rhombus. Then I will give you 2 minutes. You can note it down, and this is the parallelogram. How many axes of symmetries are there? No axes of symmetries are there. Then what is the order of rotational symmetry? That one equals to 0. I'm quickly moving to the next one. Then what is the next one, video? That means rhombus. Look at this one. This one, yes, rhombus. Just wait a minute. Quickly note it down. Right. I'm quickly moving to the next shape. What is that one? Rhombus. Right. Now you can see the rhombus here. I'm just going to delete this one. Then rhombus. Very good. Rhombus means all 4 sides are equal. All 4 sides are equal. Rhombus means all 4 sides are equal. Right? Let's check whether what is the order of rotational symmetry of the rhombus. Now, just try to do that one with me, right? Quickly, just try to think. Click on the video, try to think how many axes of symmetries will be there for the rhombus, and what will be the order of rotational symmetry for the rhombus, right? Just quickly think, and you can write down your answers quickly. Right, now, then time is over. Just quickly tell me, can you mark the number of axes of symmetry? Yes, definitely I can do. Look at this one. Right. Then you can fold along the diagonal, through the diagonal. So it will take equally two sides. So that means number of axes of symmetry in the rhombus, that part equals to 1. And we can draw another axis through this line, then 2 below. So that means how many axes are there for the number of symmetry? That means 2. Axis, number of axes of symmetry, that equals to 2. Very good. Then what is the order of rotational symmetry? Then just quickly tell me, what is the order of rotational symmetry? To know that one, we need to rotate that figure, right? Let's try to rotate that one, right? Okay, I'm just going to rotate this one. No, 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 this is not the original shape. No, no, right. Look at this one. One times. Then again, I'm just going to rotate that one. No, 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 no. Then 2 times. How many times it will coincide with the original one? How many times it will equal for the original one? 2 times. When you are going to rotate one round, how many times it will equal with the original one? 2 times. That means what is the order of the rotational symmetry? That means 2. Order of rotational symmetry, that means 2. Right? Okay. Then you can draw this one, right? Okay. Now I'm just going to move to the next shape. What is that one? Let's quickly move to the whiteboard. Then I can show you about the regular pentagon. Right. My dear student, next one. What is that one? Regular pentagon. Right. Look at this one. You know the pentagon, right? This one. Regular pentagon. There is a very famous building, right? Administrative building is there. So that name is pentagon. Pentagon means you can see 5 sides. 1, 2, 3, 4, and 5. 5 sides are there. So you can see this one. Right? Pentagon. Then first let's try to understand how many axes of symmetries are there. So you can observe this one, right? You can place this one, right? I'm just going to draw the line, right? Okay, by using this line, then if you're going to fall through this line, definitely you can get 2 equal parts. If you're going to fall through this line, right, definitely you can get another 2 equal parts. Then how many axes of symmetries are there? 2. And this one, right, 3 axes of symmetries are there, and 4, right? That means 4, okay, and this one also 5. 5 axes of symmetries are there, right? Then 1, 2, 3, 4, 5. That means what is the number of axes of symmetry? 5 axes of symmetries are there, right? 5 axes of symmetries are there. Now I'm going to rotate that one. Look at this one. Right. Wait. Look at this one. Then I'm just going to mark the boundary lines. Right. I'm just going to mark the boundaries. Right. This one is okay. Right. Wait a minute. And I'm just going to mark the boundary lines. 1, 2, 3, 4, 5 vertices are there. Right. I'm just going to rotate that one. Look at this one clearly. So this is the starting point, okay? Right. I'm just going to rotate this one. Just check that one with me. 1 is equals to original shape, 2 times, 3 times, 4 times. Now that one is here, right? 4 times, then 5 times. So what is the order of rotational symmetry? What is the order of rotational symmetry? That means 5. What is the order of rotational symmetry? That means 5. Right? Okay, then you can do this one. Right? Just try to do that one. Right? Just try to observe this one with me. Right? You can separate, you can draw pentagon on the half sheet or the A4 sheet, then you can separate that one using scissors, right? Then try to do this one. Karanna meka hari. Then 5 is the order of rotational symmetry. Regular pentagon. Now it is your duty, regular hexagon, then just try to find the number of axes of symmetry of a hexagon and just try to find the number of rotational symmetry on the hexagon. Then it is up to you, right? Just try to do that one. Then we can move to the summary. Now I'm just going to mention the summary and we need to learn some important points regarding the summary, right? Quickly note it down and draw the figure. Right, my dear student. Now, then I'm just going to take a summary. Now we just observed how many axes of symmetries are there in the equal triangle, parallelogram, rhombus, rectangle, square, regular, pentagon, and you just observe how to what is the number of axes and the order of rotational symmetry in the regular hexagon. Now you can see, so this is the summary, right? Now you can see this is the summary regarding all these plane figures. Now this one is really important. Look at that one so closely, right? Look at that one so closely. Equilateral triangle, parallelogram, rhombus, rectangle, right? Regular pentagon, regular hexagon, and regular octagon. What are the regular shapes? Regular shape means all sides are equal, all angles are equal. Equal triangle is there. Square is there. Regular pentagon is there. Regular hexagon is there. And the regular octagon. Those are the main figures now. Look at the axis of symmetry and the order of rotational symmetry. Look at the axis of symmetry and the order of rotational symmetry. Axis of symmetry in the equal triangle and the order of rotational symmetry on the equilateral triangle. Axis of symmetry of the square, order of the rotational symmetry of the square. Axis of symmetry of the regular pentagon, order of the rotational symmetry of the regular pentagon. All are equal. Now we can get the first point. What is that first point? Now we can get the first point. What is that one? Right? In a regular shape, both order of rotational symmetry equals to number of axes of symmetry. Right? Number of axes of symmetry. Right? So that is the first point. That is the first fact we can clear according to this table. Right, according to this table, right? So then after, if a geometrical plane figure which has rotational symmetry, is also biometrically symmetrical, that means geometrical figure which has rotational symmetry is also biometrically symmetrical, then its order of rotational symmetry is equals to the number of bilateral symmetry, right? Third one, just consider the parallelogram. Right? Parallelogram, look at this one. No any axis for the symmetry. There are no any axis for the symmetry. Just look at the parallelogram. There are no any axis for the symmetry. But look at the rotational symmetry equals to 2 times it will coincide with the original one. දෙපාරක් පැටියෝ parallelogram එකක් කරකවද්දී දෙපාරක් equal වෙනවා. හැබැයි no any access of symmetry. කිසිම access එකක් නැහැ symmetry. Right? That means, what is the meaning of that one? What is the meaning of that one? A figure which is not bilaterally symmetric, that can have a rotational symmetry. Plane is not a bilaterally symmetric plane figure, but maybe it have a rotational symmetry. Right? So those things are very clear, right? To this one. Then we need to clear out some points. Then we can move to the exercises. Then after, I will explain all those. Right? Right. Then quickly move to the exercises. We need to complete all the exercises from the beginning. Then quickly move to the exercises. Right, my dear student. Then as I shown this figure, right, in the screen below, then I just explain you what are the relationship, what are the facts, right, clear according to this table. Look at this one, then I need to explain just one more further thing, right? Look at this one, right? That means, look at the order of rotational symmetry. Look at the order of rotational symmetry, 3, 2, 2, 2, 4, 5, 6, and 8. Look at the order of rotational symmetry. That means if the order of rotational symmetry of a plane figure is 2 or more than 2, is 2 or more than 2, more than that figure, then we can say that figure have a rotational symmetry, right? Are you 100% clear with that one? If that order of rotational symmetry of a plane figure is 2 or more than 2, then that figure is to say to have rotational symmetry. That means all these figures have rotational symmetry. Yes. Why? What is the reason? Because all these figures having order of rotational symmetry equals to more than 2, greater than 2. Just think like this. I'm quickly, yes, or more than 2. Just think I'm taking another shape. That means I'm quickly moving to some shape like that heart shape. I'm just quickly drawing to heart shape. Heart shape. Look at this one. I'm drawing a heart shape. Now this is the heart shape. No outlines. Right. Now look at this one. Right. Now look at this one. I'm just going to rotate a full round. No. 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 Then I'm just going to take a full round. No. 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 Then yes. That means how many times? Only one time it will equal for the original one. After completing a one rotation, after completing a full rotation, how many times it will equal to the original one? Just one. එකයි වැඩි original එක. එකපාර equal වෙන්නේ නේද? That means order of rotational symmetry equals to 1. So that means order of rotational symmetry, right? That means order of rotational symmetry equals to 1. Neither. That means order of rotational symmetry equals to 1. That means, sorry, order of rotational symmetry equals to 1. That means, right? So this figure is not having a rotational symmetry. That means this one is not having a rotational symmetry, right? Because one, if you're having a rotational symmetry, then order of rotational symmetry should be greater than 2. But here 1, then order of rotational symmetry is a figure has rotational symmetry is greater than 1. Therefore, for this figure, this is not having a rotational symmetry. Then I think you are 100% clear with that number, right? Okay, then we can quickly move to the exercises. I'm just quickly moving to the exercises. Then I will do some exercises. Then you can do that one by yourself, right? I'm quickly moving to review exercises of the symmetry lesson.
Right. Copy the following plane figures in your exercise book. Draw the axis of symmetry on each figure. Right. So you can draw this one. Then I can say this is the axis of symmetry, equally divided into two parts. This is the axis of symmetry. This one, this is the axis of symmetry. Rhombus. There is a rhombus, right? That means this will be the axis of symmetry. This one also axis of. Then I'm quickly moving to the exercise number 2. Select the figures that are bilaterally symmetric from the following and write down their numbers, right? Bilaterally symmetric plane figures. Look at the first one video, then I think first one, no. So we can't find out the bilateral symmetric plane figure on this one. So therefore, no any bilateral symmetric plane figure for the first one. But second one, yes, we can equally divide into two parts. Second one, we can equally divide into two parts. Yes, then we can. Third one, I think no. But fourth one, yes, fourth one we can fold along through this axis. Then we can get two equal parts. So that means what are the figures? Figure number 2 and figure number 4. Likewise, you can do, right? Just try to do this one. Karanna. Right, okay. Question number 3. I'm quickly moving to the question number 3. The dotted line shown in the figure divides the given rectangle into equal two parts. Okay. Samit said that his dotted line represents an axis of symmetry of the rectangle. Explain why his statement is not true. I will explain that one. Why that statement is true or false, right? Not true. Because if you are going to fold along this axis, if you're going to fold that sheet along this axis, then the two parts that will be not equal, right? That will be not equal. In a rectangle, we know that rectangle, there are two axes of symmetries, but what are them? So this is the first one. On this way, then we can take axis of symmetry. On this way, we can take the axis of symmetry. That means there are two axes of symmetry on the rectangle, but that dotted line is not axis of symmetry, right? Exercise number 4 is there. Just try to do that one by yourself, video. Right. Then I'm quickly moving to the rotational symmetry part. That means rotational symmetry. Then activities are there. Just try to do this one. I'm moving to last exercise 11.1. Right. Draw the isosceles triangle ABC in your exercise book as in the figure and draw its axis of symmetry. Copy the triangle ABC onto the plastic paper and find out whether the isosceles triangle has rotational symmetry. Right, then this is up to you. Now you can do this one. Take a piece of paper, then you can draw isosceles triangle on the ABC like ABC. Then you need to do this one, right? I will help you. This will be the axis of symmetry. But it is your duty. You need to observe how many times it will take equal for the original one when you're taking a one rotation. Just try to do this one. Exercise 11.1, right? Yes. Then some questions are there. Draw the plane figure. Then you can try this question on the summaries there, right? Just try to do the full exercise 11.1, and try to do the full exercise 11.1, right? Then it is up to you. Question number 3 also there, right? Every bilaterally symmetric plane figure has a rotational symmetry. No, that is wrong. Why? I will explain that one to you. Just take letter A. This one is bilaterally symmetric plane figure, but look at this one. Then if you are going to rotate that one, it will take only one time for the original one. That means no any rotational symmetries for the every bilateral symmetric plane figure. That one is false. Every plane figure which has rotational symmetry is also bilaterally symmetrical. No, false. I will tell you example. Look at the parallelogram. Look at the parallelogram. Order of rotational symmetry is 2. That means there is an order of rotational symmetry. But look at the number of axes of symmetry. That is 0. So that one is wrong. That one is wrong. So second one also wrong. Second one also wrong. Third one. If a bilaterally symmetric plane figure, has rotational symmetry, then the number of factors of, if a bilateral symmetric figure has a rotational symmetry, then the number of factors of symmetry equals to order of rotational symmetry. What about that statement? What about that statement? Are you agree with that one? Are you agree? If a bilateral symmetric plane figure has a rotational symmetry, right? Rotational symmetry, then the number of factors of symmetry is equals to the order of rotational symmetry. Right. Let's quickly check that one. Let's quickly check that one. I'm quickly moving to the table below. Right. Order of rotational symmetry 3, number of axes of symmetry 3. Yes. Order of rotational symmetry 2, number of axes of symmetry 0. Right. So we can neglect that one. Then 2, 2, 2, 2, 4, 4, 5, 5. Yes. That means true. That means true. Right. Then if you're having any bilateral symmetric plane figure, so that means order of symmetry equals to number of factors of symmetry. That one is true. Right. The point of interaction of the axis of symmetry of a bilateral symmetric plane figure which has more than one axis of symmetry is its center of the rotational symmetry. The point of intersection of the axis of symmetry of a bilateral symmetric plane figure which has more than the one axis of symmetry is its center of rotational symmetry. Yes, I think that story is true, right? Look at this one. The point of interaction of axis of symmetry of a bilateral symmetric plane figure, then I will draw the, just try to just take the triangle. Right, okay, look at this one. Let's take a triangle. The point of interaction of axis of symmetry. Right, okay, axis of symmetry like this. So we can take like this. Then this is the point of axis of symmetry, intersection of axis of symmetry. Right, symmetry by of a bilateral symmetric plane figure which has more than one axis of symmetry is center of rotational. Yes, that one is true. Then if you are going, this is the center point of the, this is the center. That one is true. Very good. I'm quickly moving to the last one on this panel, right? Last one video. Scaling triangle does not have a rotational symmetry and also bilateral symmetrical. Scaling triangle means all three sides are unequal. All three sides are different, like this, like this. Then, right, rotational symmetry, let's try to do that one. Right, okay, let's try to do this one. I'm just drawing a scaling triangle. Insert shape, then I can draw the scaling triangle. Right, okay. This is the scaling triangle. Then you can see that one. I'm just going to delete this one. Then what is the question video? Scaling triangle does not have a rotational symmetry and also not bilateral. Yes, this one is biometrically not symmetric plane figure. That one is 100% clear. See, see a side. But let's check about the rotational symmetry. So you can clearly see when I'm going to rotate that one, no, it will not equals to only one time. It is equals for the only one time for the original position. That means what is the order? Order equals to one. But if you're having the rotational symmetry, that means order should be two or more than two. So therefore, scalene triangle does not have a rotational symmetry. That one is true. Then I think you have a clear idea, right? Then I think you have a clear idea about the rotational symmetry and plane symmetry, right? Okay.
Right, my dear student. So this is the last chapter, that means summary regarding the first lesson of your second term. What is that one? Symmetry. Right, now you know about two symmetries. What is that one? Bilateral symmetric and rotational symmetry. So I have given the summary. A shape has rotational symmetry when it looks like the same after some rotation. That means when you are going to rotate a figure, then it will take for the original one. That means it will looks like the original shape. So we can say yes, that have a rotational symmetry. Number of times it coincide with the original one. Number of times it coincide with the original one is known as order of rotational symmetry. Number of times it coincide with the original one is known as order of rotational symmetry. If the order of rotational symmetry of a plane figure is 2 or more than 2, not 1, 2 or more than 2, then that figure is said to have a rotational symmetry. That means order of rotational symmetry should be equals to 2 or more than 2. Then we can say then its shape has a rotational symmetry, right? This is the first lesson, right? I think you're 100% clear up to this point, right? Now you can understand this one. Then you need to do the questions on the exercises, right? What is the exercise number? 11.1 in your textbooks, right? Okay. Then thank you very much, my dear student. So I think this one is very clear to you. Then if you have any doubts or questions regarding this lesson, so we can discuss this one in the class, right? So see you soon on the lesson number 12 video in grade 8, right? Thank you very much. Have a nice day. Thank you all.